the fifth International Conference on Knowledge-Based and Intelligent Information and Engineering System. In this video tutorial, I'm going to explain the research paper with the title An Efficient Learning Weight of Elman Neural Network with Chicken Swarm Optimization. After the title of the researchers, let's talk about the paper outlines. So in the paper outlines, there is the introduction to Elman recurrent neural network and its problems, objectives of the research papers. After that, I'm going to explain the chicken swarm algorithm. And after the chicken swarm algorithm, I'm going to explain the results analysis on the proposed algorithm. And at the end, I will explain the contribution and conclusion of the research paper. Moving forward, first of all, I would like to explain the artificial neural network. So, artificial neural network is an information processing model that mimics the biological nervous system, such as the brain processes information. Artificial neural network is working on the basis, or it is working like the mimicry of the human being or the biological neural network. It consists of small processing units known as artificial neurons, which can be trained to perform complex calculations, and the small units called neurons from which the artificial neural network are made. And artificial neural networks is implemented in these in the following areas, such as we can use the artificial neural network in the big data, except that we can use in the medical diagnosis, defense industries, early warning systems, and other detection systems. We can use the artificial neural networks. After the artificial neural network, moving towards the multi-layered feed-forward neural network. So we can see from its name that it is a feed-forward neural network. So the feed-forward neural network consists of the input layers, means it can have the input layers, the hidden layers, in the output layers. Among many different neural networks models, the multi-layer feed-forward neural network have been mainly used due to their well-known universal approximation capabilities. So we can see from its name that it is the feed forward neural networks. It's always go in the forward direction and cannot back in the backward direction. As you can see, then it goes the forward pass. After the feed forward neural network, I'm going to explain the recurrent neural network. So recurrent neural network has local feedback connections to some of the previous layers. It has different feed forward network in the sense of that there is at least one feedback loop. So recurrent neural network is basically different from the feed forward neural network. It has a memory buffer, and we can store some results here in the recurrent neural network. It is after the recurrent neural network, I'm going to explain about the backpropagation algorithm. So backpropagation algorithm is a common method of artificial neural network training for backward propagation of errors. BPN is also known as supervised networks, widely used in solving many real-time problems in the world. As you can see that it has number of input layers. Here in this diagram, we can see the three input layers. And after that, we have the hidden layers. So there are two number of hidden layers in this backpropagation algorithm, and at the end it have the output layer, means the one output layer. So the data passes from the input layers moving towards the hidden layer, and at the end it goes to the output layer. So it going in the forward pass as well as it coming back in the backward pass. So we can say that it is the backpropagation algorithm. The problem statement of this research work is it has the slow convergence rate and easy struck at the local minimum. Several modifications are suggested to improve the convergence of the element recurrent neural network. As we can see, uh, these are the different things: learning and rate and momentum, and after that, careful selection and initial weights and biases. Network topology is discussed. After that, second order methods and meta-heuristic chicken swarm algorithm is hybrid with it. So these are the few modifications which are made to this algorithm. Now we can see the paper objectives. So the paper objectives, objective number first is to remove the local minimum problem in Elman neural network algorithm by enhanced the learning weights with chicken swarm algorithm, and the second objective is to compare the performance of the proposed chicken swarm Elman neural network with artificial bee colony back propagation genetic algorithm neural network and back propagation neural network in terms of percentile accuracy and mean square error. Now we can see the chicken swarm optimization algorithm. So chicken swarm optimization is a new by inspired, you can say it is a native inspired algorithm developed by Meng for easy for ease. The chicken swarm optimization algorithm selected the behavior of chicken by the following rules. So rule number first is chicken swarm algorithm includes several clusters. Each cluster has a couple of hens, chicks, and a dominant rooster. In the second part is the personality of chickens, hens, chicks, and rooster depend on their values of fitness. Chicken having best fitness will be regarded as rooster. The chicken with numerous weakest fitness will would be chosen as checks. Dominance relationship and mother-child relationship and hierarchical order in a cluster will continue unchanged. Chickens trials group mates rooster to hunt for food while they can stop the one from eating their own food. Assume chicken will randomly be stolen good food already searched by others. The chicks hunt for food around the mother hen to dominate. The dominant individual have an advantage in struggle for food. This is uh, the proposed model for chicken swarm at Elman neural network algorithm. Here it starts at the Elman neural network structure, and after that it initializes the swim population, and then it updates the by weights and the weights and by values epochs are started, and when maximum epochs reach, so it will end. Or we can, in another way, it starts at the uh, Elman neural network structure, initialize the chicken swarm, and after that it input pattern and calculate the output from Elman neural network, and after that it calculate the mean square error, the target error, and a maximum reach to the maximum epochs, and at the end it ends. Now we are going to discuss about the result and analysis. So first of all, we are talking about the iris dataset. Iris dataset are used. So here the network is used. The network topology used is 453. So this 4 shows the input layers, the 5 show the hidden layers, and the 3 shows the output layers. Here the learning rate is zero point 0.3 and minimum mean square error is 0.001. The maximum epoch set for this algorithm is 1000 epochs. So the different algorithms used in this research article. So accuracy and mean square error performance are calculated on the basis of the accuracy and mean square error of the iris classification problem. So if we look, these are algorithms which are used. ABC, BP, artificial bee colony are hybrid, is hybrid with the back propagation algorithm. So it gives the mean square error, and train 70% training data. It gives the mean square error of 0.434 and accuracy of 82%. In testing, it gives the accuracy the mean square error of 0.0335 and gives the accuracy of 85.64%. And after that, the genetic algorithm neural network gives the mean square error of 0.125 and gives the accuracy of 89.35 and 70% of training data, and say 30% testing data. It gives the accuracy the mean square error 0.2124 and gives the testing accuracy at 88.31. And now we look at the performance of the back propagation neural network. So it gives the mean square error of 0.3236 and 70% testing data, training data, and gives the uh, accuracy of 94.47 with 70% training data. And if we look the mean square error and on the 30% testing data, so it gives the 0.3177% accuracy mean square error and 94.43% of 94.343 percent of accuracy with the 30% testing data. And after that, chicken swarm element neural network gives the mean square error 99.96. It gives the 99.96 96 accuracy on training data and gives the 99.98% on the testing data. If we look at to the graph, so these different colors are used. So if we look at this blue color, so this shows the um, mean square error of the G genetic algorithm neural network. This color shows the mean square error of the big propagation neural network, and this yellow color you shows the mean square error of artificial big propagation algorithm, and this line shows the mean square error of the chickens from Elman neural network. Now, if we look at the 7-bit parity data set, so here the network topology used is 7 is the input layer, 5 is the hidden layer, and 1 is the output layer. Here the learning rate used is 0.3%, and the minimum mean square error used is 0.001. So if we look at these models, so artificial bee colony gives 0.21 mean square error and 96.01 accuracy with 70% training data and mean square, and after that it gives 0.2250% mean square error genetic algorithm with neural network and 87.50 uh, 87.50 up accuracy with 70% training data, and after that the big propagation algorithm gives the 0.227 up mean square error, while it gives the accuracy of 94.96 with 70% of training data. And at the end, the chickens from Elman neural network gives the accuracy of 99.96 with the uh, with the 70% of the training data. Some, these are some of its graphical representations. So graphically, it shows that chicken from gives the best accuracy. Now we can see the contribution and conclusion. So chicken from Elman neural network convergence rate improved greatly by the introducing chicken from optimization algorithm. So the Elman here, the chicken from optimization technique is hybrid with the Elman neural network, which gives and attain the better accuracy. And on the other hand, if we see more achieved more accuracy on iris and 7 bit parity data set, so it gives the better accuracy on these data set. So now the acknowledgement, the author would like to thank the organizer of the 25th International Conference on the Knowledge-Based and Intelligent Information and Engineering System for accepting this research. And these are the references. Thank you so much.